So today we're going to be solving multi-step equations. To begin with though, I want to go over some vocab terms that are going to be important that I use constantly. The first vocab word is terms, and terms, the amount of terms that an expression has, um, depends on how many items are between a plus or a minus sign. So off to the side over here, I can see that I have this plus sign and I have this minus sign. So that means I have 1, 2, 3 terms. So anytime you hear me talking about the first term, that would be the term that starts it all off. The last term would be the one that is at the very end. Second, third, et cetera, would be somewhere in the middle. So that is what I'm talking about by terms, is um, the numbers and the variables that are separated by pluses and minuses. So next up we have coefficients. So coefficients are going to be the number that is being multiplied to a variable. So here we have 2 and 3 are both considered to be coefficients because they're being multiplied to a variable. Next we have constants, and constants are going to be numbers that do not have a variable with them, meaning that they do not vary. So there's nothing that is unknown being multiplied to it. It is just always 2. So that is why it's constant. It is a constant 2 always. So another important 2 words that I use a lot are going to be monomial and binomial. So those of you that are going to be taking some kind of Latin or whatnot, really the important piece is going to be the prefixes. So mono meaning single and bi meaning 2. So a monomial is a single term. So as an example, you see this 2x. A binomial means that there are 2 terms. Like a bicycle has 2 wheels, a binomial has 2 terms. So you can see this example of 3x minus 2. So this has 2 terms. So I'm going to be using these 5 words a lot, and anytime I'm going to be adding more words, I will do some kind of quick session like this at the beginning of a lesson. So here we go. We are going to be solving using multiple steps. So to begin with, one thing that you may want to know is that there's no wrong way to go about and solve. There is you can't actually do that mathematically. That may be wrong, but if you are properly doing correct math the entire time, you cannot mess up solving. Now, there are a lot of easier ways of solving. Again, does not mean that it is the correct way or the best way, but it's pretty much a easier or a quicker way of doing that. So a lot of you already know the orders of operation, being PEMDAS, which stands for parentheses, exponents, multiplication, division, addition, and subtraction. So when you're solving though, we actually go the opposite direction. So when you're solving, what you're going to be doing is you're going to be looking for things that are being added or subtracted to the variable you were trying to solve for. After you've done that, then you're going to look for any multiplication or division that's happening, and then you go and you do any exponents, which is going to be a different class than this one, and then parentheses last. So looking at this first example, we have 4x minus 7 equals 11. So the thing I'm trying to solve for is this x. So the variable I'm solving for is x. So I need to ask myself first, do I have anything being added or subtracted to it? And I can see that I do. The first thing that I have is this minus 7, so I'm subtracting 7. So that's the first thing I want to get rid of. So it is going to be doing the exact same math. So we're subtracting 7 here, so I need to do the opposite, which would be adding 7, because negative 7 plus 7 gives me 0, which is what I'm looking for. And what you do to one side, you have to do to the other. So here, these two terms are just going to cancel, leaving me with a 4x on the left side, and 11 plus 7 gives me 18. So we did the first step. We got rid of any addition or subtraction. So now I'm on to the next thing. I need to ask myself, do I have anything being multiplied or divided? And as we can see, I'm still solving for this x, and I have that 4 being multiplied. So now I just have to get rid of that multiplication, and the opposite of multiplication is division. So this time I'm going to be dividing both sides. I'll put it in green. I'm going to be dividing both sides by that 4. Because again, 4 divided by 4 is going to cancel to give me 1, and 1 times anything is still the same, so that's why I'm trying to get that to be 1. So this leaves me with x equals 18 over 4, and that is a fraction that I am capable of simplifying. Both of these are even, which means they're both divisible by 2, so this gives me 9/2 as a final answer. So I would highly recommend you keeping your answers in fraction format. It's a whole lot easier to check your answers if they give you decimals than it is if you had written it in decimal and you needed to try to figure out what the fraction was. So keep your answers in fractions. So again, I went through this PEMDAS, I just went backwards. And since addition and subtraction are interchangeable, and same with multiplication and division, that's why I'm looking at those two things in pairs. So let's try the next example. So we have negative 4/5 plus 2/3 x equals 3. So again, the first thing I want to look at is, do I have anything being added or subtracted? And I can see that I do have something being added or subtracted to my variable I'm solving for. So that my variable is this x. And I have an addition sign, so I can get rid of this negative 4/5. So I'm going to start by getting rid of this negative 4/5. So the opposite of a negative 4/5 is a positive 4/5. So I'm going to add 4/5 to both sides. So on the left side, these are going to cancel to 0, giving me 2/3 x equals 3 plus 4/5. So off to the side, we can do that math. So 3 plus 4/5, I need to get a common denominator. So I'm going to do the butterfly method. But for those of you that are concerned about what the denominator is for this 3, remember 3 divided by 1 is still 3. So we can just put a 1 there to help us out. So we can do our little butterfly. So we have 3 times this 5 gives me 15. And 1 times that 4 gives me 4. And my denominator would be 5 times 1, which is just 5. So now that we have that same denominator, I can just add numerators. So this gives me 19/5. So that means 2/3 x equals 19/5. So now we're on to the next part. So we need to get rid of any multiplication or division that's happening. And here I have something being multiplied to my x, so I need to get rid of it. So remember from the last session that since this is a fraction, I can just multiply by the reciprocal of that fraction instead. So I'm going to multiply both sides by 3/2. Because this 3 divided by this 3 cancels, this 2 divided by this 2 cancels. So that's why I'm multiplying by the reciprocal. So I end up with x on the left side, and on the right side, I'm just going to go and multiply straight across. So we have 19 times 3, which gives us 57, and 5 times 2, which is 10. So those things do not simplify, so that is our final answer. All right. So looking at this next problem, we have x minus 2 divided by 4 equals 3. So here's where I'm going to be using one of those vocab words. Anytime you see a fraction, and that fraction has something larger than a monomial, so a binomial, for the most part in this class, all you will see are binomials. Anytime you see a binomial in the numerator or the denominator, what I want you to do is I want you to put that binomial in parentheses. So I am going to put this x minus 2 in parentheses. And that's very important because if you go back up to our PEMDAS, it says that parentheses is the last thing that we get to touch, which means that I cannot touch what's inside of these parentheses until I've dealt with everything else. So that means I need to get rid of this 4 in this denominator first. Well, that's just a multiplication and a division piece. So that means I can do that. I can get rid of that 4. Since it's being divided by 4, all I need to do is multiply both sides by 4. So 4 divided by 4 cancels. So on the left side, I'm left with x minus 2 equals 12. So notice that there's no more multiplication or division happening to these parentheses on the left side. Now that we've gotten rid of everything on the outside of the parentheses, now we can deal with the parentheses. And how we're going to deal with the parentheses is get rid of them. We no longer need them. So now we kind of start over again. It's almost like a loop. Now that we've gone through parentheses, let's ask ourselves the first question again. Do I have anything being added or subtracted to what I'm solving for? And I do. I have this minus 2. So I need to get rid of it. So to do that, I'm going to add 2 on both sides. So this would cancel, leaving me with x equals a 14. So again, anytime you see parentheses, anytime you see a binomial, I want you to put it in parentheses. So anytime you're doing division or some kind of fraction, put it in parentheses, because that tells you, hey, I have to deal with everything outside of that before I can touch what's inside of it. So I have 2 u-tries for you to try. We have a negative 3 plus 2x equals 15, and we have a 2x plus 6 all divided by 4 equals 10. So pause this video and try it out. All right, so on the first one, you should have gotten x equals 9, and on the second one, you should have gotten x equals 17. So one way that you can always check yourself is to plug in your answer back into the original equation and see if both sides equal the same thing. So if I plugged in this 9 into the left side, this would be negative 3 plus 2 times 9, and we're going to see what this equals. So we have negative 3 plus 2 times 9 is 18. Negative 3 plus 18 gives me 15. So both sides equal the same thing, so I know I did it correctly. So if you had any issues, try to go line by line in your own work, see if you can find your own mistake. Again, being able to find your own mistake is the best thing you can learn to do in a math class.